Hi everyone, welcome to this video. This is the last video for chapter 6. So we're looking at transformations of functions. So I've got three different functions listed up here. So we've got x squared, 1 on x, square root of x. Now, just as a quick exercise, pause the video, draw your axes, and have a go at drawing these three graphs. Okay, so once you've had a go at that, x squared just generally, okay, looks like this. 1 on x, you should have something that looks like this one. And square root of x, okay, just looks like that. Now, we're going to have a look at first what we can do to translate what we call translate, so that's moving the graph left or right. We can also have a look at what happens or what do we do when we move it up or down. Okay, so underneath there, okay, new set of axes. Now, y equals x squared, we've had a look at this in previous chapters. What happens moving it left or right? Okay, so I'm just going to have the example. What does the function look like? So y equals, and we've moved it across 2. Okay, we would write that as y equals x take 2 squared. Okay, we've moved it to the right 2 places. Again, we've swapped around the signs. Okay, so we've moved across 2, but we have -2 in the sign in the brackets there. Now, if I had going to the left, okay, I moved it to the left 2. It would be y equals x plus 2 squared. So that's moving it left and right. Moving it up and down as a third instance. Okay, I've got y equals x squared. Moving it up so it looks like this. Well, I can write that as y equals x squared, and I'm going to move it up 2, so it's outside the square part. Okay, down here, same function, just it'll be x squared take 2. I've moved it down 2. So see the difference there, how we've got -2 inside the brackets, moves it left and right, inside the brackets. Outside the square part, or outside the brackets, we move it up and down. This sign doesn't change. If it's +2, we go up 2, -2, we go down 2. Okay, similar effect here, except instead of the turning point, so square x squared, we're looking at the turning point. 1 on x, we're looking at the asymptotes. Okay, so you've got a vertical asymptote and a horizontal asymptote. So moving it left and right. Alright, I want to move it to the right twice. Okay, moved it to the right. We have the same shape, except now it just looks like this. Okay, not much different. Now, what does that look like in terms of the function? Well, again, we'll use our brackets. It's next to the x. So x take 2. We've moved it to the left. To the right 2 places. And similar effect when we move it to the left. Okay, so I've moved it down to -2. My graph will be the same shape. Looks like that. Now, it'll be 1 over x plus 2. Alright, brackets are good. So I moved it to the left 2 places. And similar effect to our x squared, moving it up and down. If I want to move it up 2, I'm moving the horizontal asymptote up 2. Yeah, got lots of lines going on here now. Okay, the vertical hasn't moved, but I'm moving the horizontal up 2, so it'll be y equals 1 on x and plus 2 outside. And last example, the y equals square root of x. We just have a look at this point here. If I want to move it to the right 2 places, okay, same shape, I've moved it to twice. It'll be square root of x take 2, and the take 2 is inside the square root part. If I want to move it to the left, it would be y equals square root of x plus 2. And if I want to move it up or down, okay, this point here, I've moved it up 2, so it'll be y equals square root of x plus 2 outside the square root part. And down here would be a similar effect, except we'll have y equals square root of x take 2. Okay, so really, in summary, we look for a point where we can move it up or down, left and right. For the x squared, we look at the turning point. Moving it up or down, it's outside the square function. If we're moving it left and right, we look at inside the square, inside the brackets. For 1 on x, it'll be the asymptotes. So moving it up or down, we look at the horizontal asymptote, so moving it up 2 or down 2 or whatever it is. Left and right, we look at the vertical asymptote, and that's inside the brackets. For our square root part, we're looking at the first little intersection, or the first point. Okay, moving it up or down, left or right, same situation. Outside the square root for up and down, inside the square root for left and right. Okay, next part is to look at reflections. Now, I've got the same graphs. What happens to them, or what do we do to reflect them? I'm just going to draw in what the graphs look like to start with. So this is going to be in green. Okay. Now, a reflection in the x-axis. Okay, so just imagine we've got a mirror on the x-axis. We're going to flip it, or what happens to the mirror image of it. So all these points will go down like that. Okay, so what have we actually done? Well, all these x values, the corresponding y value is going to be negative. So for this point here at 2, initially we had 4, 2 squared is 4. But now we've got the same point at 2, but now it's minus 4. So what's actually happening? We've got y equals 2 squared, and that gave us 4. Now we've got y equals the same point, but now we've got minus 4. So where does that minus come from? Well, it has to be outside that square part. If it's inside, we'll get a positive number. Okay, minus 2 squared will give us 4. So it has to be outside the square. So we put around brackets, we'll have y equals minus, and it'll be x squared that looks like that. Okay, that's a reflection in the x-axis. Unfortunately, it's hard to see for a reflection in the y-axis, so that's putting a mirror down the vertical line. Okay, so all the points on this side will now go on that side, all the points on this side will go to that side, and that's essentially this one, so it's inside the square part. As you can see, it's symmetrical, so all these points are going to be the same points on this side, and that's because we're squaring it. Okay, so 2, we get 4, so minus 2 will be the same point. So it's a really bad example for the square part. We'll have a look at what happens on this one. which is similar. So that's the x squared. 1 on x. Now, same thing, I'm going to have a look at that point at 2. Okay, I want a reflection in the x-axis. So all these points here are going to come down on this point, so we'll have a look. So those points will go there. These points will now go up there. So what's actually happening at this point here? We've got a half, but down here we've got minus a half. So initially we're starting with y equals 1 on x. Now at point 2 we have y equals 1 on 2. For our reflection we get y equals minus a half. So again, it's a similar case to this one. We have, for a reflection, a minus outside the x part. Okay, so that's a reflection in the x-axis. Now, we get a very similar case for when we have a reflection in the y-axis. So again, put a mirror down the y-axis. All these points here are going to get reflected along here. So we get the same graph. So this point goes there, etc. And all these points go over there. So a reflection in the x-axis ends up being the same as a reflection in the y-axis. Now I'm just going to tell you that it'll be 1 over minus x. Okay, in brackets again, like this. This is what we would have for a reflection in the y-axis. Okay, but 1 over minus x is the same as minus 1 over x. Okay, you get the same points, and that's indicated by the graph there. We'll have a look at the same thing for our square root part. Okay, all these points here get reflected in the x-axis, so they all go down there. Okay, what happens? Well, at this point 2 we get, actually we'll have a look at 4, just because it's easier to work with. Okay, square root of 4, we get 2. But down here we'll get minus 2. So what's happening? Again, we have y equals square root of 4. Initially we get 2, but after our reflection we get minus 2. So where does that minus come from? It has to be outside the square root part. So we can say y equals minus square root of x for a reflection in the x-axis. Now, we can't get a reflection in the y-axis because essentially what we need to do is y equals the square root. Oh, actually, no, we can. Sorry, I said we can't. Okay, inside the square root part. Okay, this point here at 4. Okay, it has to be at minus 4 now. Okay, that point there, we get reflected along the y-axis. Again, a mirror down the y-axis. The 4 goes to minus 4. Now, what happens at minus 4? We get y equals the square root of minus 4. Two negatives cancel out, so we get 2. So again, we get up to 2, but this time it's getting reflected this way. So see the difference here? We have a reflection in the x-axis that goes down like that. A reflection in the y-axis ends up going that way. Okay, different to these ones. Okay, this one we got the same for both cases. This one was symmetrical, it was hard to see. But this one, it's quite easy. Here's our original function. Here's a reflection in the x-axis. Here's the reflection in the y-axis. So we can start to make a summary. Okay, I've got some pre-written notes here. So a horizontal translation, we say y equals f of x take h. Okay, we've moved it to the right h units. Okay, minus, meaning we go to the right. Let's go back. Let's have a look. So how has that worked? Okay, here's our original function, y equals x squared. We had 2 units to the right by x minus 2. So how does that relate to that? We started with y equals x squared. Now a translation, h units to the right, we're saying 2 units to the right. So it means h is going to be 2. We say y equals f of x take 2. Now I say f of x is actually y, which is x squared. So just bear with me for a moment. So I can say f of x equals x squared. Okay, that's what my function is. Now I'm translating it by this one. So f of x take 2. Take 2, sorry. X take 2, I'm saying whenever I see x, I'm going to put x take 2. Okay, f of x is x squared, so I say x take 2, that's what my x is. Now that's being squared, and that's where it comes from. Okay, y equals x take 2 squared. This is what we have. A little bit complicated. Now, another example, we'll have the 1 on x. And we moved it to the right again. So I say f of x equals 1 on x. I want a translation 2 units to the right. So I'm saying for my function, whenever I see x, I'm actually going to put x take 2. So f of x take 2 is our original function, 1 over x, but now instead of x, I'm putting x take 2. That's all I do. So my translation is f of x take 2 is 1 over x take 2. Moving it up and down. Okay, remember it's outside the square part. For this one. Okay, I'm moving it up 2 places. So I'm going to move it up to f of x plus 2 or plus k or take 2, take k. So I say I've got my original function, which is x squared, and I've moved it up 2. Okay, for this one I moved it up 2, so f of x, my original function is 1 over x. Moving it up 2, it's f of x plus 2, so I've got 1 on x and I'm adding 2, and that's what we have here. Okay, I've moved it up 2, and same thing for taking away, I'd go down. Okay, so that's the first 2 summaries there. So f of x plus k, that's the example I just shown where we've moved it up or down to. So it's got a vertical translation, k units upwards. This one, horizontal translation, h units to the right. If it was plus k, it would be, plus h, it would be h units to the left. If it's minus k, k units to the right. K units down, sorry. So that's a little table on page 319. And we've had a look at reflections here, so we've got a similar case. Okay, we're going to make a bit of a summary. So my next section, okay, y equals minus f of x gives a reflection in the x-axis. That's this one here. So f of x equals x squared. Now I want a reflection in the x-axis, so using this, it's minus f of x. So I've got my original function f of x, and I've got a negative in front of it. Okay, when I do that, probably should put brackets around it. So that's a reflection in the x-axis. Now it turns out that a reflection in the y-axis is f of minus x. Okay, see the difference how we've got a minus x in front of, or inside the brackets, outside the function. So we'll have minus x, and that's all squared. For our 1 on x, our original function is 1 over x. We want a reflection in the x-axis, so we have minus f of x. So we say minus 1 on x. Okay, there's my original function. For f of x, I just put a minus in front of it. Now for a reflection in the y-axis, it's f of minus x. So I'm saying my original function, but instead of x, I'm putting minus x. Now essentially they're the same thing. Okay, I've just got a minus outside, I've got minus on the bottom, they end up doing the same thing, and that's what's showing on the graph here. And then for my square root function, okay, f of x equals square root of x. I want a reflection in the x-axis, so it's minus f of x. I get minus square root of x. My original function square root of x, I just put a negative in front of it. Okay, reflection in the y-axis, f of x equals square root of x. Okay, I use f of minus x. Again, see the difference? I've got a negative x inside the brackets. The negative is outside the function. So I say, whenever I see x, I'm now putting minus x. And that's all I do. So see how they're completely different? And that's what we get here, two different graphs. Okay, I'm going to leave the video there. So that's the most important parts. We'll have a look at dilations in class, and we'll do a few examples. So the main point is to get the table down from 319, 321. So that was the translations left and right, up and down, and the reflections in the x and y axes. And we'll have a look at dilations in class. Okay, so that's it for now. Thanks for watching.